Hi and welcome to another audiophile video. This time I'm talking about the SABA receiver, the 9241, which was available in 1978, and the speakers, the SABA Professional 1300. All the components are in my family since 1978. Nothing ever has been repaired. The amplifier is still in original condition. In this video you can expect a detailed dyno video. I made a power test and also a sound demonstration. Let's talk about the SABA receiver first. As I said before, it's made in 1978 and the price was around 1,500 German marks. The ratings of the amplifier were 70 watts into a 4 ohm load continuous power at 0.03% THD. The receiver performed well in several magazines, so let's talk about the loudspeaker. They feature a 12-inch woofer, which was made by Vigo Acoustic. The company was called Gottlob Wittmann und Söhne, and the model of the woofer is PMT 310/50/100. It has an aluminium basket and a voice coil of 52 millimeters. The mid-range driver of the loudspeaker was from ITT. The model number is LPKM 130/50/120T. It has been used in several European loudspeakers. So for example, there was Bang & Olufsen, the M100, the M75 and the M102, the Transonic Live TL500, Tandberg Studio Monitor, also used in Meridian Boothroyd Stuart M1. You have two tweeters which were made by Philips or Valvo, and the model number was, if I remember correct, AD0162 T8 or T4. You can turn the treble more to the right or to the left with a treble localizator. It was able to reproduce frequencies up to 16 kilohertz and then it goes dramatically down. Treble is a little bit dampened, and some of the people back then claimed the loudspeaker sounds a little bit like standing behind a curtain. The wall thickness was 25 millimeters, that is around 1 inch, and one loudspeaker weighs around 20 kg. And now let's see what the SABA receiver can do on the dyno.
The receiver is connected to the dummy loads. I have connected a 4 ohm resistor to the left channel and a 4 ohm resistor to the right channel to have both channels driven into full power. And I use a USB sound interface to simulate my input signals, and everything is connected to the scope so we can measure the output power. I am testing continuous power and some dynamic burst power tests to simulate music power. Let's zoom to the scope and check out what this amplifier can put out. And now I'm starting with a continuous power test with a 1 kHz input signal. It drives the amplifier right to the clipping point. Here we get into clipping. I reduce my input signal. It shows maximum voltage 28 volts. You have to divide this by 1.414 to get the RMS output voltage. And I go to the top of the waveform. So we have 27.8 volts. The amplifier delivers 99 watts into a 4 ohm load per channel, both channels driven into full power. Continuous power test, but this time with a 50 Hz input signal. Oh, I go back. It says 27.6 volts. I think it's fair if we calculate with 27 volts. The amplifier delivers around 93 watts into a 4 ohm load per channel, both channels driven into full power. Remember, the amplifier is rated 70 watts at a very low THD. Now I'm testing with a 1 kHz burst input signal. That means I have 20 cycles, 1 kHz, to simulate something like music power. Here's my burst. You can see it goes lower. In this case, I try to get all the cycles to the same voltage level, so I observe the last cycle. And this should be clip free. So I'm going to reduce my input signal until we get rid of that clipping. We can take this one and it says 30 volts. I take another shot of the whole burst to check out if all the cycles are at the same voltage level, and that's the case. The amplifier delivers 115 watts into a form load per channel, both channels driven. Now I'm testing with 1 kHz and 8 cycles here in this case. I show you how the signal looks like. And I'm going to observe the last cycle if it's free of clipping. And these burst tests simulate a crest factor because music material has a higher crest factor than pure sine wave input signal, which has a crest factor of 3 dB. The music varies from, I would say, 18 dB to 6 dB. And let's see if we can squeeze out some more. This test method is a lighter load to the amplifier's power supply. No clipping. Oh, we get higher voltage clipping here. It says 31.2 volts. I go a little bit deeper. I would say let's calculate with 30.8 volts. The amplifier delivers 121.5 watts into a form load per channel, both channels driven. Now I'm testing the amplifier for absolute short-term peak RMS output power. I have an input signal of 1 kHz for just 1 millisecond. That means one cycle. There's my cycle. I can go higher until clipping. Still no clipping. There's clipping. I go back a little bit. Let's take this one. It says 33.2 volts. I would say let's calculate with 32.6 volts. For just 1 millisecond, the amplifier is able to put out 133 watts into a form load per channel, both channels driven. Now I'm going to test the amplifier with an 8 ohm load per channel, both channels driven. 1 kHz continuous power test. Clipping. I reduce my signal. It says 33.2. Let's calculate with 33 volts. The amplifier delivers 69.8 watts into an 8 ohm load per channel, both channels driven into full power. Continuous power test with a 50 Hz input signal. 8 ohms per channel. Oops. I think that looks okay. It says 32.8 volts. I go to the top. Okay, let's calculate with 32.6 volts. The amplifier delivers around 68 watts into a 8 ohm load per channel, both channels driven into full power. Dynamic power test 1 kHz, 20 cycles. I go to the last cycle to check if there's clipping. Now I increase my input signal until we get clipping. Here we have clipping. Let's calculate with 34 volts. The amplifier delivers around 74 watts into an 8 ohm load per channel, both channels driven to full power. Dynamic power test 8 milliseconds. Let's jump to the last cycle to check the clipping. And there's our signal. It says 34.8 volts. I go to this position. Let's calculate with 34 volts. With 8 milliseconds, the amplifier delivers also 74 watts into an 8 ohm load. Now I'm going to check out what the amplifier can put out with just 1 millisecond. We have strong clipping. I go back. Still clipping on the negative waveform. That is something we can use. So it says 36.8 volts. I would say it's fair if we calculate with 36.2 volts. For 1 millisecond, the amplifier puts out 84 watts into an 8 ohm load per channel, both channels driven. The amplifier is not rated to handle 2 ohm loads, but I'm going to do a test. I connected two 1 ohm resistors in series to the right channel and also two 1 ohm resistors to the left channel. In case you don't believe me, this is a 1 ohm resistor. Continuous power test with 1 kHz into a 2 ohm load per channel, both channels driven into full power. I drive the signal into clipping. There we have distortion and problems. I go back until we have a clean signal. That's clean enough. We have 19.4 volts. The amplifier delivers 94 watts into a 2 ohm load per channel, both channels driven. Dynamic power test, 1 kHz, 20 cycles. I observe the last cycle for clipping. Now I'm increasing input signal. No clipping. There we get distortion. I reduce. I think we can use this one here. And now we have a higher output voltage. We are at 22.4 volts. We have a small increase in output power. The amplifier delivers around 125 watts into a 2 ohm load per channel, both channels driven into full power. Dynamic burst test with 8 milliseconds. I observe the last cycles. I increase my input signal until we get clipping. There we have clipping. (23.2 volts). The amplifier delivers 134.5 watts into a 2 ohm load per channel, both channels driven. And now I'm doing the short-term maximum peak RMS output power test for 1 millisecond. There's our cycle. We can increase input signal. Still no clipping. There we have clipping. That's okay. So we have a peak voltage, it says 28.4. Go to the top of the waveform and I will calculate with 28.2 volts. For just 1 millisecond, the amplifier is able to put out 198.5 watts into a 2 ohm load per channel, both channels driven into full power.
If you are also interested in vintage SABA equipment, then I can suggest an interesting link for you. Just visit www.magnetophone.de, jump to SABA forum. This is a message board where you can interact with some users of the website. Just register, it's for free. If you like this video, why not leave a thumb or better subscribe to my channel? Thank you very much for watching and see you next time for another video. Bye bye.